Hello! A method to obtain a system of linear differential equations is to rewrite a high-order linear differential equation as a system of first-order differential equations. And first-order differential equations are much easier than second-order, so awesome! However, there's no such thing as a free lunch, as we obtain a system of equations instead of just one. Still, thinking about a system of first-order equations is often easier than thinking about higher-order equations, and this rewriting allows us to treat the higher-order equations in the same way as the systems of equations that we want to study anyway. Let me show you how this works using some examples. First, let us consider the basic mass spring system. M times the second derivative of y plus k times the derivative of y plus c times y equals 0, where y of t gives the location of the mass at time t, m is the mass, k is the friction coefficient, and c is the spring constant. As you can see, this is a linear second-order differential equation. Now we introduce the velocity v equals y prime. We want to find equations describing the derivatives of y and v. For y, this is easy. Y prime equals v, as that is how we chose v. Notice that the derivative of v is the acceleration y double prime. Using this, we can rewrite the original equation as m times v prime plus k times v equals c times y equals 0. So v prime equals minus c over m times y minus k over m times v. Thus, we have found a system of two linear first-order equations. It's useful to rewrite this in terms of matrices and vectors. For example, here we can rewrite this as the derivative of vector yv equals the matrix on the slide times the vector yv itself. The technique we used here to change a second-order differential equation into a system of first-order differential equations can be done for any linear higher-order differential equation. As an example, we consider the third-order differential equation on the screen. The first step is to introduce new variables, y prime and y double prime. We stop at the second derivative, which is one less than the order of the differential equation. If we include y, this means we have three variables, as many as the order of the differential equation. Next, we consider the derivatives of these three variables. As before, the derivatives of y and v are determined by the defining equations for the new variable. Only for the last variable a, we need to use the differential equation to find an expression for its derivative a prime. Remember to replace all the other derivatives in the differential equation with the new variables, so y double prime becomes a, etc. Finally, we see that we have a system and can write it using vectors and matrices. The strategy shown here works for all high-order linear differential equations, so try it out yourself. Goodbye.